Hey, welcome to the Explainer. Today we're diving into something really cool in TypeScript. Two superpowers, really. It's all about understanding data by its shape and functions by their signatures. Now, this might feel a little different at first, but trust me, it unlocks some incredible flexibility in your code.
So let's start with a question that really gets to the core of how TypeScript thinks. What if your code cared more about what an object can do instead of just what it's called? It's a fundamental shift, right? Instead of getting hung up on names, TypeScript is all about structure and capabilities. And that's exactly what we're going to break down.
Okay, so here's the plan. We'll kick things off with those two big powers I mentioned. Then we're going to really dig into what's called structural typing and a neat little detail about fresh versus stale objects. After that, we'll look at function overloading, and finally, we'll tie it all together and see why this stuff actually matters when you're writing code.
All right, so let's get into it. TypeScript's awesome flexibility really boils down to two main ideas. First, how it understands your data, which is all about its shape, and second, how it understands your functions, which is all about their signatures. Let's tackle shapes first.
And that leads us right into our first major concept, structural typing. This is a game changer. In TypeScript, it's not the name that counts, it's the shape of your data, what it looks like.
Yeah, you might have heard this called duck typing. You know the saying, if it walks like a duck and quacks like a duck, well then it's a duck. TypeScript basically runs with that idea. It doesn't care what you officially name the type. As long as the properties, the shape, match up, then for all intents and purposes, the types are compatible.
Now this slide really gets to the heart of what makes TypeScript different. A lot of other languages use what's called nominal typing. With them, the name is everything. The types could have the exact same properties, but if the names don't match, no go. TypeScript, on the other hand, uses structural typing. It's like it cares about what's inside the box, not the label you slapped on the outside.
Okay, let's make this super concrete with an example. Imagine you have a ball type, and all it needs is a diameter. Then you've got a tube type, which has both a diameter and a length. See where this is going? You can totally assign a tube object to a variable that's expecting a ball. Why? Because the tube has everything the ball requires, and then some. It fits the minimum shape.
But, and this is crucial, you can't do it the other way around. A ball object doesn't have that length property that the tube type needs. The shape just doesn't fit. And this is where TypeScript saves your bacon. It catches this mismatch right away and tells you a property is missing, preventing a nasty bug down the line.
Okay, now here's where things get a little more nuanced and honestly pretty clever. TypeScript doesn't always apply these structural checks in the same way. It actually has two different modes, a really strict check for brand new objects and a more relaxed one for objects that have been around for a bit.
And this slide breaks it down perfectly. When an object is fresh, meaning you're creating it as a literal right where you're using it, TypeScript is super strict. It demands an exact shape match, no extra properties allowed. But the moment that object becomes stale, which just means you've assigned it to a variable, TypeScript chills out of it. It only checks for the minimum required properties. That's exactly why our tube to ball assignment worked a couple slides back.
All right, so we've established that TypeScript is all about the shape of your data. But what about functions? Well, it has an equally smart way of handling them. This is where signatures come into play, and they let a single function wear multiple hats, depending on how you call it.
Yeah, a great way to think about this is like a restaurant's signature dish. You know, the name on the menu is the same, but it represents a very specific, special combination of ingredients. It's the same idea with the function's signature. It's that unique combination of parameters and what it returns that makes it identifiable.
So what function overloading really lets us do is create one single function, let's call it add, that can intelligently handle different kinds of inputs. Maybe it adds numbers, maybe it concatenates strings. By defining different signatures, we make the function's purpose crystal clear and our code becomes way more intuitive to use.
And the structure for this is always the same, which is nice and predictable. First, you declare all the possible ways the function can be called. Those are your signatures, or overloads. Think of them as the function's menu of options. Then, you write one single implementation that has the actual code to handle all of those different scenarios. Let's look at a length function, for instance. We can define a signature for it that says, hey, when I get a string, I'm going to return a number. So when we pass it the string hello, it knows exactly what to do. No confusion. It just gives us back 5.
And now, check this out. We're using the exact same function name, length, but this time with a signature that accepts an array. We give it an array with 3 items, and bam, it returns 3. This is the magic of overloading. One name, 2 totally distinct type-safe jobs.
Okay, so we've gone through these two pretty powerful ideas, shapes for data and signatures for functions. But so what? What's the real-world benefit? Why should you start thinking this way when you sit down to code?
At the end of the day, this isn't just theory for a textbook. Thinking in shapes gives you incredibly flexible and reusable code. And defining clear function signatures gives you code that's safer and practically documents itself. When you put them together, you get a system that helps you squash bugs long before your code even thinks about running.
So really, embracing these ideas helps you write code that's just more adaptable, more robust, and way easier for you and your team to understand. By focusing less on rigid names and more on structure and what your code can do, you really start to unlock the full power of TypeScript. So the next time you're writing some code, will you be thinking in shapes and signatures?